Hello everyone, welcome to Keep Learning at the rate Be Creative. For more such mathematics related video, please like and subscribe the channel. So here we have a theorem which says the tangent at any point of a circle is perpendicular to the radius through the point of contact. First let us understand the statement. What does this say? The tangent at any point of the circle. So we have a point P and at this point we have this tangent xy. This is perpendicular to the radius through the point of contact. So we have the radius OP where to the point of contact. So here we have to draw the radius which connects the point of contact, and this radius, or you can say the tangent, is perpendicular to the radius. So this tangent xy is perpendicular to this radius OP. This is what we need to prove in this theorem. Now before moving to the proof of this theorem, we should have a clarity in our mind related to a concept. That is that the shortest distance between a point and a line is perpendicular distance. That is what we are saying, that if we have a point and a line, then the shortest between that point and the line is the perpendicular distance. Let us understand what we mean. So here we have a point O and we have a line M. So if we have to have a shortest distance between this point and this line, that will be the perpendicular distance. Let us understand. If we drop the perpendicular OP on this line M, then we have to prove that this OP is the shortest one. So let us take any other point, arbitrary point, you can say on line M. Let it be X or X dash. Now here you can see that when we connected OX, we have a right angle triangle OPX, or if we would have connected OX dash, we would have a right angle triangle OPX dash. Now here we can see that this angle is 90 degrees, so definitely OX or OX dash will work as the hypotenuse in the right angle triangle. And we know that in a right angle triangle, hypotenuse is the longest side. So if you move this point X, if it is any other point other than P, then you can see you will always have a right angle triangle in this way, and this OX length will always be greater than OP. Why? Because in right angle triangle we know that hypotenuse is the longest side. So here if you take any other point other than P on this line segment, you will have a right angle triangle, and OX will always work as the hypotenuse and it will always be longer than OP. So OP is the shortest distance between this point O and the line M. So I hope this point is clear, that the shortest distance between a point and a line is perpendicular distance. Now let us move to the proof of the theorem. So here in this theorem, what is given to us is a circle with center O and the tangent xy to the circle at point P. So here we have a circle with center O and xy is the tangent which is tangent to the circle at point P. So we can say that this point P is the only point common in the circle and the tangent. Now what we need to prove is that OP is perpendicular to xy. So we have connected the center with the point of contact, so definitely this is the radius, and we need to prove that OP is perpendicular to xy. For this we will take a point Q other than P on the line xy, and then we are going to join OQ. Now when you have joined OQ, here you can understand that Q will lie outside the circle because the common point, the only common point between the circle and the tangent was P, which we have already connected. So definitely Q will be any other point than P. Also it will be lying outside the circle because xy is the tangent. Now let OQ intersect the circle at point R. So definitely since point Q is outside the circle, if you try to connect center with Q, it is going to intersect the circle at certain point that we will name as R. Now we can very clearly say that OR will always be less than OQ. Why? We know that by the statement of Euclid that the part is always less than the whole. So OR is a part of the line segment OQ. So definitely OR will be less than OQ. Now we also know that OP will be equals to OR because R is a point lying on the circle. So definitely OR will also be the radius of this circle. So therefore OP and OR are the radius of the same circle, so they will be equal. Now from point 1 and 2 we can conclude that OP will be less than OQ. We have replaced this OR with OP because they are equal. So here we have OP less than OQ. Now this will always be following because Q we have taken an arbitrary point other than P on this XY. So if you take Q any other point, definitely this statement will always be true. Now if such thing happens, so what we can say? We can say that OP is shorter than any other line segment joining O to any point of XY other than P. So if we take any other point other than P on this XY, then OP will be the shortest distance. Now OP is the shortest distance between the point O and the line XY. So we know that the shortest distance between a point and a line is the perpendicular distance. So what we can conclude from this, that OP is perpendicular to XY. This OP will be perpendicular to XY because this is the shortest distance from point O to the line XY. So I hope you have understood the proof of this theorem. Some more result which we can say about this statement. First point will be, by theorem above we can also conclude that any point on a circle there can be one and only one tangent. So if you have any point on the circle, at that point you can have only one tangent, because for example if you take point P and you connect OP, then to OP you can just draw only one line which will be perpendicular to OP. If you take any other point, then the tangent will be different because the line perpendicular to that radius will be different. Now next point which we can conclude is that the line containing the radius through point of contact is also sometimes called normal to the circle at that point. We know that normal is the perpendicular to the surface, that is, here the surface will be as your tangent XY and OP will be perpendicular to that. So sometimes it is also called as normal to that point. I hope you must have understood the theorem, and if you want to see some more videos like this, please like the video and subscribe the channel. Thank you.